cloud. Okay, so I'm doing a imaginary exam example. Plus 6 times 75 times 2 times 65 plus, oh no, I got too many timeses in there, plus 45. So let's get rid of some of those timeses for pluses. Enter, divided by 16, and we get 77.5. Okay, and so that would be an average grade for this imaginary class. Okay, and kind of to be expected, it's kind of like right in here. Okay, and so I think that this is just an important idea, is to kind of mentally imagine where the average is. Okay, so for example, in this problem right here, this imaginary shape right here, let's imagine it doesn't have a hole cut out of it. Okay, if initially it didn't even have this, let's suppose initially the shape looked like this. Okay, well, where is the average position? Let's say the average Y position in that case. Okay, well, it seems to me like it's going to be like right in the middle. Okay, now what if, on the other hand, then what happens when we start adding things to the top? Well, that should shift the average Y position upwards, because now we've got more like kind of area into the topper in the upper area. So we might say, well, that's going to put it, like right in here. Okay, now what happens when we say, okay, well, what about if I come in here and I cut a hole in this thing? Okay, I don't want to get rid of those dots, but so we've got, this was the original spot. Now it's moved upwards a little bit. What happens when we cut a hole in this thing? Okay, what does that do? Well, that kind of makes this triangle more important, essentially, because there's less area down low. So it's actually going to pull it even further upwards. So maybe this dot's going to end up like, it might even end up there. Okay, so this is the idea of finding the average Y position, the centroid, the average position. So the centroid would actually have two positions. It would have an X bar and a Y bar. In this case, I've only looked at the Y bar. The X bar is actually going to be a little bit to the left. And I'll talk about that in 1 second. I do also want to note that if the shape just looked like this, okay, the centroid would still be right in the middle. So it's not in the shape. So now we've got a rectangle, and we've cut out this circle. The centroid is still right there in the middle, but it's just not a part of the original shape, and that's okay. Okay, it doesn't have to be actually in the shape. So like when we look at this one, if I wanted to figure out where the X position is, okay, then I start thinking about, well, where is the most kind of area? Well, there's more area on this side than there is on this side. Okay, and that goes all the way down, right? So it always has more area on the left than it does on the right. So the centroid position is probably going to be somewhere like maybe here. Okay, a little bit to the left of center, and certainly, kind of up high. Okay, because we've got more area up top, and we've got more area on the left. Okay, so it might be like right in here. Okay, and that might be easier to see in a shape like this. Okay, so like in a shape like that, if I had, gotten rid of, well, there you go. So we could, I always like to think kind of starting like, okay, if we got this shape, all right, well, that's pretty easy. The center in the X and the center in the Y is going to be like right there. Okay, seems pretty straightforward. But then if I add another shape here, okay, so now I've got this kind of composite shape. Well, you can kind of imagine that now this thing is top heavy. This would be like if I gave an exam and a whole bunch of people got A's. Okay, so I had like all these people got A's, and then let's erase all these, like let's suppose, and then we got 2 in all these other categories. Now, maybe this wouldn't be a good performance as a professor, like maybe I should be a little bit unhappy, but you can imagine that the average grade here is going to be pretty high, right? Like as a professor, I might almost even ignore these people because hopefully I wouldn't, but but you can see that like the average here is probably going to be, pretty high, right? Like maybe, like if I ignored the A's, the average is probably right here. But if I take the A's into account, that's going to pull this thing higher and higher, and it's going to pull the average higher and higher and higher. The same thing here. I've got all this area on top. So the average, of just the, just this bar is like maybe here, but then because of all this area at the top, it's going to get pulled upwards. So maybe we're up here. Okay. Now the same thing will happen in the X direction. Initially, this thing was, right here, but now because I've got all this area over here, basically this thing is probably going to be pulled a little bit this way. Okay, so maybe we end up out in empty space. Maybe we don't, I don't know, but it is going to be pulled to the left by all this area. Okay, so basically every piece of area has an effect on the whole centroid, and every piece of area needs to be equally weighted. Okay, if we're doing a centroid of area. If we were doing a centroid of the mass, then you'd have to take into account the density of whatever it is we're working on. Okay, so this is the idea of the centroid, and what's his name? Jeff Hansen does, when he does his video, he does the Centroid of Texas. I don't like Texas because, well, not because I have anything against Texas, although I did live there for a while, but it was not my favorite place to live, but, to each their own. But I don't really like Texas as a shape to do because it seems like the centroid is going to be like right here. It's too obvious, right? It would have been better if you had done Florida, because the centroid of Florida is less obvious, because the centroid of Florida is probably right out here. Okay. And, it's less clear where it is. The centroid of Texas, well, we just look for the center and it's probably pretty much right about there. Okay. Anyway, so this is the idea. And now we're basically going to be doing, what we're basically going to be doing is we're going to be doing this calculation. Okay. And the key here is basically we're going to be multiplying instead of just adding all these little boxes. Okay. And we're going to add all these little check marks. Okay. And we're going to add these little check marks essentially when we integrate. So adding all the little check marks, that's the equivalent almost of integrating. But adding the boxes, that's going to be kind of what we do when we do composite areas. Okay. And really there is an appropriate time to use each. Okay. So, and I think when the appropriate time is should be pretty clear. So let's delete all this junk. Let's just clear all. Okay, so I think I have, hold on, I have to change screens real quick. Oh yeah, oh, you know what? That is that's not the problem I wanted. Well, let's do this one. Okay, so I'm gonna go from practice 8 centroids, and I'm gonna do number 2. These are, these problems can be a little bit slow. You know what, maybe we'll do number 1. 1's probably easier. Yeah, 1 is easier. So let's start with number 1. Okay, so number 1 looks like this. Okay, I'll do 2 of these. Okay, so here's number 1 from practice 10 or practice 8. What practice is this? Practice 8 centroids. Okay, and it looks like this. Okay, and so the top there is 135 millimeters, 100 millimeters, and 60 millimeters. Okay, so what we're looking for is, this is what's given, and the required is X bar, Y bar equals what? Okay, and I write it as an ordered pair because it will be a position. Okay, now my expectation here should be like, where's this thing going to be? Okay, and I always like to think about this because otherwise I just kind of, I don't know about you guys, but if I don't think about where it's going to be, I kind of just dive into the calculation. I start, and what ends up happening is I end up getting an answer without really thinking about what it is that I'm doing. Okay, and again, it's kind of like what I just described. So in the Y, like if I think about this box first, okay, I think it's going to be right here, but then I've got all this extra area in the triangle, so it's going to pull it downwards. Okay, and then I've got this triangle, and the triangle is weighted heavily to the left. Okay, like there's more area to the left than there is to the right. Like if I just kind of look at these little areas, so my expectation is that it's going to pull this way. Okay, so my expectation is somewhere over there. So if I were to guess, and this is a total guess, okay, it's going to be less than half of 135. So this is going to be my guess. I'm going to put a guess in like red here. Okay, so it's going to be less than half of 135 for the X. So let's go ahead and make that like, oh, I don't know, 60 millimeters. And then in the Y, well, let's see, we got to go up 60. But then it's not going to go up the full 100. So, it won't, I mean, it's not going to go up to the full half of that, which would be another 50. So that'd be 110. So let's maybe make this like 95. Okay, this is totally a guess. I haven't worked this problem already, so so we'll see what happens. Okay, so then what we need is we kind of need a formula. Okay, and so here's the formula for X bar. Okay, so basically you can see, hopefully, when you look at this, that this is what we call a composite shape. It's two shapes. And there's two ways to do this composite shape, but the formula is, and I guess depends on who writes it for you. This is X bar A over the sum of the areas. Okay, so in other words, this is kind of like, yeah, let's see how to think about this. So this is the total area on the bottom. So you can think about it as the total number of people who took the tests. Okay, so this is the sum of all the smaller areas, and then the X bar area is, this is the number of people who took it, who got that grade, and this is the grade that they got. Okay, so that's kind of, I don't know, that's how I think about it. Okay, so so what we're going to do, so that's X bar, and of course Y bar looks similar. Y bar equals Y bar A summation over the sum of the area. Okay, notice the total area will be the same in both, so there's no need to do that twice. Okay, all right, so what we're going to do is, once I can leave total area here. Okay, and this one, when you're doing a composite shape, so this is two shapes, and what we're going to do is we're going to split it this way. I will note that you could also do it another way. You could do the whole thing as one giant triangle. I'll still kind of show that in green. As one larger triangle, and then subtract off this triangle. Okay, and we'll do that one. We'll do that kind of example in a second. But right now, what we're going to do is we're going to do this rectangle is one area, and this triangle is a second area. Okay, and so the way that most people do this, and I have no problem with this way, is you create a chart. Okay, and the chart looks like this. There's like area. Okay, and we're basically looking at what's up here, and we're going to do this as a summation. So we're going to do area. Let's see, what else do we need? Well, we need X bars. Okay, and then based on over here, I'm going to need Y bars. And then to make my life easier, I'm going to do, let's see here, X bar A and Y bar A. Okay, so this is just a chart that we're going to create. Okay, so I don't like, the only thing I don't like about this is we can kind of get lost in the, like, I'm just calculating a whole bunch of stuff and not thinking about kind of what's going on here. Okay, so, and it's kind of inevitable in this. Usually it's not so much. So millimeters. Okay, this is millimeters cubed. This is millimeters cubed. Okay, so it's important that whatever unit you're using, you use all the way through. Okay, so you can use millimeters here, and that's fine. Okay, so let's just go into it. So I've got two shapes, and I'm going to kind of do these shapes one at a time. So here's shape one. All right, so shape one, let's see what we got here. It's a rectangle, so the way we get area is we do length times height. Okay, so we got 100 times 135, so that's 13,500. Okay, pretty straightforward. Now we need the X bar. Where is the center? So this is of the shape. Okay, sometimes you will see this. Sometimes you will see this written as X tilde to indicate that it is the centroid of the shape. Okay, your textbook uses an X bar. It's neither here nor there. Okay, so so what we're doing now, and we need to focus, we're in the X thing. And if you don't know where the centroid of a shape is, so for rectangles, pretty straight, it's easy because it's in the middle of the shape. But you can have triangles, you can have circles, you can have all kinds of different shapes. And so there's a chart in your book on page, let's see, 239, and that will have all the shapes for you, I think. Well, I should have most of them anyway. And if you can't find it, then what you do is you type up, you just type in centroids of shapes into the internet, centroids of shapes chart. into the internet, and you will be able to find what you need. Okay. So anyway, so X bar for this shape, so I'll do this in, I guess, red. It's like right there in the middle, right? So that's half of 135. So that's the X coordinate of it. Okay, so I'm gonna do X bar, Y bar from this is the origin right here, 0, 0. Okay. And so how far this way do I go to get to this centroid? Well, it's going to be half of 135. Okay, so 135 divided by 2 is 67.5 millimeters. Okay, now we need to do Y bar. Now the Y bar, of course, is, or maybe not of course, but that's going to be the position of this. So it's, let's see, so it's from here. So we go up 60, and then we go half of that 100. So that's going to be 110 millimeters. Guys, please interrupt me if you don't know how I'm getting these numbers. Okay, so now what we'll do is basically I'm going to do X bar times A. I'm going to do Y bar times A. So basically I'm just going to multiply. So for X bar A, I'm going to multiply this one times this one. So let's see here. 13,500 times 67.5, and I get a really massive number, 911,250. 911,250. Okay, and then for Y bar A, I'm going to do Y bar times the area. So that's going to be 110 times 13,500. Okay, that's wow, that's 1,485,000. 1,485,000. Okay, big numbers. Okay, so so hopefully, I think what you can see here is if the shape is complex enough, this can get a little tedious. But well, the math isn't hard. Sometimes it can get confusing about, like, you know, where we're thinking things through or anything. Anyway, but it's all just multiplication. So now we're going to go to this triangle, and if you look at that chart, let's see here. So for a triangular area, and this is kind of tricky, is so if we have a triangle, okay, whatever the triangle may look like, it says that the centroid is at h over 3. Okay, so it's like, this is my height, and it says it's h over 3. Now, a key thing, and this is a key spot that students get confused about, is, okay, h over 3. So the centroid height is h over 3. But does that mean that it's h over 3 from the top or from the bottom? Okay, does that mean it's like right here? Or does that mean it's like right here? Okay, this is in the vertical. Okay, and I hope that what you can see, and this is why I spent a little bit of time in thinking about this, is that this thing is bottom heavy. Okay, on the top, there's almost nothing up here. So that's why the centroid has been pulled downwards. So it's h over 3 from the bottom. Okay, so in this case, when I look at this thing, okay, and I should note that it's also in the x direction, it's h over 3 going this way. Now it's a different h, right? But it's h over 3 off of this side. Okay, so when I look at this drawing here, it's going to be 1/3 of the distance this way, and it's going to be 1/3 of the distance this way. Okay, you know, the most of the area is down towards this corner. Okay, down towards this corner. Okay, so what we need to do here, but, you know, of course, I'm looking at this triangle. Okay, so in this case, it's 2/3 the way up this way. Okay, in the y direction, so that's going to be 60 times 2/3. That's 40 in the y bar. Okay, and the x bar, it's going to be 135 divided by 3 going this way. What's that? Now is that divisible by 3? Yes, it is. Is it 45? I think it's 45. 135 divided by 3, 45. So this is 45 millimeters. Okay, and that's how you get the location of the centroid of that shape. Okay, now to get the area, we'll do a half of base times height. So the area will be 1/2 of 60 times 135. So it's 30 times 135 is 40/50. Okay, and then from here, we're just going to kind of keep on with our x bar A and y bar A. So x bar A is this one times this one. So that's 45 times 40/50 is 182,250. 182,250. And then for the y bar A, we're going to multiply this one times the area. So 40 times 40, 50 equals 162,000, 162,000. Okay, so now we need the sums. And, you know, in this case, we don't need all the sums, because what we're going to do is we're going to look up here at this thing, you know, at what we're dividing here. We really need two sums. So I'm not going to add up all the sums. So I need the total area right here. Okay, because that's on the bottom here, the sum of the areas. Okay, it's on the bottom of both of them. And then I need the sum of y bar A and the sum of x bar A. Okay, so it's just gonna add them up. So 13,500 plus 40,50 equals 17,550. 17,550, that's millimeters squared. And x bar A is 911,250 plus 182,250 equals 1,900,000 and whatever, 93500. Okay, bunch of numbers. Okay, and then 1485123 plus 162,123. Okay, equals 1,647,000. Right. And what stinks about this is you end up a lot of times you end up with really big numbers. Or if we converted all these to meters, we would end up with really small numbers. And it's like, I don't know what these numbers are supposed to be. So all we can do is then solve for them. So I'm going to do x bar right here by doing x bar equals ratio, this on top, this on bottom. Okay. So it equals, if I just kind of plug that into the calculator, divided by 17550 equals 62.308. Okay, millimeters. And y bar equals, we're going to take this value and we divide by that value. So let's see here, that's on this number. And divide by 17550 equals 93.846 millimeters. Okay. And so for in this class, I would want x bar, y bar equals 62.3, comma 93.8. Okay. So my initial guess was pretty good, right? No complaints there. Okay. Any questions on that? If you haven't watched the video yet, that was probably pretty confusing. But I'll do another one in a second. Any questions on that? Okay, I'm going to do another composite one, and then I'll move on to one where we get to integrate, which I find integration to be fun. But then again, you know, I'm the professor, so you know, that just shows that I'm crazy, right? So anyway, so let's see here. Let's clear all these drawings. Let's do another one of these. Let's see, I need to find one on my other screen here. I think. Hey, here we go. We'll do number 2 because it's got a definite negative space. Okay. Or, you know, actually, let's find one. Let's do from that same practice set. We'll do. Oh no, never mind. I'm not doing that one. That one's pretty hard. All right, let's do number 2. It's fine. It's got a definite negative space. Okay, so number 2 looks like this. Locate the centroid plane area if R equals 46 inches. Okay, so this is the second one of that same thing. And basically, we've got a semicircle. Woo. Okay, I'm really bad at drawing semicircles, apparently. You know, so here's my plane. Okay, Y and X. And here's a radius, R. Okay, and here is some bit has just been cut out of it. So let's erase that. Okay, so this thing is this thing is 16 inches. I'm sorry, 16 inches. It's not that, I mean, these coordinates don't really matter. Like I could just, by writing the wrong ones, I would still get a very functional problem. And this R is 46. So let's get rid of R. Let's choose 46 inches. Okay. So again, we want to try to figure out where the centroid is. Okay, so they want the X and Y location. So this is given. And they want X bar comma Y bar equals what? Okay. And again, just like last time, I'm going to kind of think about it beforehand. We're going to try to get a guess. And I would have guessed that if I just had the circle, it would have been down here. Like it would be a little bit closer to the bottom because there's more area at the bottom down here than there is at the top, right? So it would be below 46 inches divided by 2. So 46 inches divided by 2 is 23. So this would be on the low side of that. So maybe like 15 or so. But then we went and we cut out a whole bunch of that area on the bottom. So we cut out all this area, which is, on the bottom. So if I initially was thinking maybe like 15 or so, now I'm thinking it's been moved upwards a little bit. So in the Y direction, I'm going to go with maybe 20 inches. Okay, that's just a guess. And the X direction, I cut out all this area that was, so initially it seemed pretty obvious. A semicircle is symmetric. So it'd have to be like right there at, what's that distance? I guess if this is our origin, 0, 0. So it would have to be 46 inches here. But the thing is, we cut out all this area on the left. So that's going to move this thing to the right. Okay, how far is it going to go to the right? I don't know. So initially we were at 46. So maybe we're going to go to, I don't know, 56. Okay, total guess. Okay, and let's just see. Okay, but in this case, I guess we'll see what happens. Okay, so we're going to do the same thing we did in the last one, remembering what our formulas are. So X bar for the whole shape equals the summation of the X bars for the smaller shapes. Okay, like that. And Y bar equals the summation of Y bar A over the summation of the area. Okay, so we're going to do this. And the only difference between doing this one and the one we did last is, first of all, we've got a semicircle, which is annoying. But more importantly, we've got this negative shape. Like we've got like this shape that's been removed. Okay, so we're going to have to keep track of some negative signs in here. Let's go ahead and do this. So we'll say, so we've got two shapes, and I guess we'll do them. So the semicircle will be 1, and this, rectangle will be 2. So we'll do the same chart as we did last time. Okay, so area, except we're in inches. So this will be inches squared, X bar in inches, Y bar in inches. Let's see here, X bar A and Y bar A. Okay, it looks like we've got shape 1, shape 2, and then we've got the summation. All right. So the area of a semicircle is, let's see here. So the area of the semicircle is, so this area of a circle looks like that, and we'll just divide by 2. So if we plug that 46 inches into our calculator, let's see here. So we get pi times 46 squared divided by 2 is 3,000, let's see here, 3323.8. Okay. And X bar in this case is pretty straightforward because this thing is symmetric. So you can, let's see here. So it's going to be, what's going on here? Oh, I see. Okay. Anyway, so it's symmetric. So it's going to be this 46 inches. So we'll go 46 inches right here. Okay. And then, okay, then the Y bar, we have to get off of this chart. And the chart tells us that the Y bar is 2R divided by pi. So we have to, we have to look at it. And it basically, the chart tells you it's coming from the flat side. It's going this way. Okay, and it says that it's 2 pi over R. Okay, so R is 46. So we plug in 2 pi and we divide by 46. 2R over pi. I was like, that doesn't seem right at all. Okay. 2R over pi. Okay, so that's the Y bar. Okay, and we're just getting that off of that chart on page 239. It's actually on the same chart, but the chart goes over to the next page. So 2 times 46 divided by pi equals 29.8. 285. That doesn't seem right, but 28.285 shows that my intuition was off somehow. Why is my intuition so far off? It does say it's 2r over pi, but it seems like it should be r minus 2r over pi. This is very interesting. Take that number. Oh, wait, this should be 29.2. Sorry. There's an error here somewhere. 40 minus the answer. I don't know what's going on here. That's very strange. Huh. I don't understand. It should not be that number. All right, I'm going to come back to that. Oh, okay. It's interesting. Your book, and this is actually the number that I remember. Okay, so I need to figure out what's going on with that chart. But the formula that I remember is 4r over 3 pi, but that is not in that chart for some reason. I don't understand that. So anyway, be wary of that chart. I need to look into what's going on with this chart. Why is it? Oh, semicircular area. What is this thing? Oh, I was looking at an arc. I see. I was reading the chart wrong. Okay. So anyway, so it should be 4r over 3 pi. So let's try that instead. So 4 times 46 divided by 3 divided by pi equals, yes, that looks much more correct. 19.523. 19.523. Okay. I'm gonna do these next two in a second, just because. Well, let's just go ahead and do them. So x bar a, we take this value and multiply by that area, or that by the area. So it'll be 46 times 3323.8, and we'll get a really big number, 152894.8. Okay, and then we'll do the y bar times the a, which is going to be 19.5223 times 3323.8. Get a big number, 64890. I'm just going to keep 5 sig figs here. Okay, so then we'll do the same thing for the rectangle. And here's the rectangle. So number 2. So the area of that is length times width. So 16 times 20, which is what, 3,200? 3,200, I believe. Oh, no, it's 320? 320, sorry, 320. Okay. And then the X bar, well, we have to figure out where that is. Okay, so here's the center of this sucker. So it looks like we've got to go, so we know it's going to be 10 here. And then we need to know what this distance is, which looks like it's 46 minus 20. So that's going to be 26 inches. So this is 36. And then let's see what else. Okay, so Y bar here is going to be, well, Y bar is a little bit easier because we're just going to go up from the origin. So it's going to go up 8 right there. Okay. And then X bar A. Okay, so X bar A. So that's going to be this one times this one. Okay, so let's see here. X bar is 36 times 320 equals 11,520. And then the Y bar A is going to be 8 times 320, 2650, 2560, excuse me. Okay, like that. All right, now before we add these, there is a weird thing going on here, which is that this needs to be a negative area because it's being removed, and this needs to be subtracted as well. Okay, so that's the key trick here. Okay, is that you have to subtract those things off. Okay, so our total area becomes 3323.8 minus 320 because it is a negative area. So 3003.8 is the area. And then X bar A is going to be 152,894.8 minus 11,520 equals 141,374,374.8. It's kind of too many sig figs, but it doesn't matter. And then 64,891 minus 2,560 equals 62,331. Okay. So now we just got to plug these things into our formulas here. So X bar equals this number divided by that number. So that, so it's going to be 47.065. Okay, so we'll say X bar equals 47.1. What are those? Inches. Okay, and Y bar. Okay, so it's going to be this number, 62,331 divided by 3003.8 equals 20.751 inches, so 20.8 inches. Okay, so that would be your answer. Okay, so my guess, well, on the Y, I was pretty good. In the X, I was way off. Okay, but still, reasonable enough. Okay, I could also note that when your book solved this problem, if you look through it, in fact, this is probably a better decision. They make their origin right here, which makes their geometry a little bit easier. You can do whatever it is you want to do, but that's kind of up to you. Okay, just make your origin a place that makes sense and label it. Don't decide that your origin is going to be right here. Okay, that's a big no-no. Okay, so give it a spot that makes sense to you. Okay, and hopefully will make sense to me. All right, any questions? Okay, the only other thing that I should note is that these things can get really, really complicated. They could have added like a triangle in the bottom here, and then you just had 3 shapes, and then you would have to sum it down here, and then they could take a circle out of that triangle, and then there'd be 4 shapes, et cetera, et cetera. And all you're doing is you're just kind of working through this. So I just work a couple examples of these, and just make sure that you kind of understand the mechanics. I don't think that this is, I could see this can be confusing the first couple times you do it, and then hopefully it just you kind of fall into a rhythm with it. I find it to be, I don't know, I find it to be a little boring, but but there is kind of a bit of a thought process, especially when you're first seeing these things, and you have to say to yourself, okay, where is this thing, like what is it relative to, what does this even mean, 4r over 3 pi? So just kind of fight through it a couple of times, and I think it'll make this a lot clearer. Yes, question. Sure.
Will you provide those formulas for us on the test?
You have to get them out of your textbook, so that's why I kind of told you page 239.
I got you.
Okay, so if you look at that, the error I made when I initially had this as, what did I have it as? 2r over pi. So I got this for the semicircular arc. But this one is for the semicircle. Let's see, the semicircular area. Okay, and I should have, so that was my error. So just use the chart a couple times, and it will make sense. This is my first time using this particular chart, so that's my error, really. Okay, so let's. Okay, so I'm going to do one now. I gave this one on the test last year, and everyone should have known that this was coming. So sometimes I'm really surprised when students do poorly on certain things, when I'm like, they had to know this was coming. So that's the way you solve these if you're doing them via, via composite shape. So composite shape, it looks like you know, something out of like elementary school where we just piece together triangles and rectangles and, you know, circles and things like that. But what will happen a lot of times is instead we will end up with, you know, a shape that we have to integrate. And usually the way we can tell that is, first of all, they give us the formula. Okay, so in this one I said, so this is on an old test. So you're just gonna have to like, okay, so we wanna know, determine X bar, Y bar. Okay, now this is to me a lot harder. And it's in a lot of ways more interesting. But you know, interesting and harder, not necessarily things that students want to hear. Right. So I gave them this and I said, okay, well, here we've got a curve like that. And it's going to go like this, and this is going to be 1 meter. And this line right here, this is y equals kx to the fourth. Okay. And let's see. And so we don't know how high this is. Okay. So like my current test, everybody got a different number for, I think, k. What I give everybody a different k? I gave everybody a different k. I'm going to just solve this with the letter k. What we want to do here is we want to find X bar, Y bar. And again, I mean, this is not easy. Okay, so so here's the origin, 0, 0. And we have to solve for this. And so I'm going to do X bar first. Okay, X bar. And the formula for it looks like this, integral of, so I'm going to use a little tilde on this one. Okay, because that's the tilde of basically my little box. Okay, and one of the things that makes this hard for a lot of us is, this is, you know, this is calculus, right? We're going to have to do some calculus here. Okay, and this is going to go over the integral of dA. So what I want to focus here before I go too far into it. This is the total area of the box. So however you get, of this shape. So however you can get that is fine. Okay, this is the kind of weighted area. So, you know, of each little box. So we're talking about little boxes here, which means we're doing exactly what we just did, except we're doing it with calculus. So it's going to be a little bit annoying, confusing, et cetera, et cetera. So in the homework that I just assigned, I asked you to set this up using both horizontal and vertical boxes. And so I'm going to solve for X bar, and we're going to do it both ways. Or basically, we're going to set it up both ways, and we're going to decide which way is easier. Okay, so the first thing that's going to happen is, okay, well, I need the coordinates right here. Okay, so what I do to get that is I know the X coordinate is 1 meter because I just wrote it right here. It's 1 meter from here. So to get the Y coordinate, I'm going to plug 1 meter into this formula. Okay, and I'm going to get, well, Y equals K, right, times meters to the fourth. So it's going to be K, it's just K. Okay, and that's going to ultimately have a unit of meters. I'm not going to write that there because that just gets confusing. So we're just going to say 1 meter times K. Okay, so there's our thing. Okay, now to set this up, what we're going to do is I'm going to draw the boxes. Okay, and this is straight up calculus stuff. So here's my little box. Okay. And I want to note that this coordinate right here, okay, the coordinate at the top center of that box is X comma Y. Okay, let's not overthink it. It's just X comma Y. Okay, now we will kind of make it more complicated in a second. Okay, the thickness of this box, okay, that's a dx. Okay, great. So if I'm going to do this, I guess I'm going to do this twice. So this will be the vertical boxes. It looks like I just kind of started with those first. And then we'll do a horizontal box. Okay, so in the vertical boxes, so a little dA, okay, we're integrating these differential areas. So for this, okay, the vertical boxes, dA equals, well, we want the area of the box. Okay, so it's going to be length times width. Okay, so the width is dx. Okay, and the length is the height of that box. So that's going to be y. Okay, Okay, let's go ahead and get x tilde while we're here. Okay, so the centroid of this box is about right there. It's halfway up. Oh, sorry. Yeah, it's halfway up and it's halfway to the left. Okay, actually, let's go ahead and do x bar and y bar. Okay, so the x bar in this case, or the x tilde, is, let's see, so it's going to be, it's just x. Okay, the y tilde, well, it's halfway up, so it's going to be y over 2. Looks like I'm actually doing both of these at the same time, so I hadn't really planned on that, but it's okay. Okay. So let's see. So that's vertical boxes. Let's do the horizontal box. Okay. Now again, I'm going to put a big dot right here. Okay. I'm going to erase this formula right here, and I'm going to move it out of the way because, so let's just say y equals kx to the 4th. Okay. This is x comma y, x comma y. Okay. So, and then this width right here, that's dy. Okay. So dA in this case, well, the thickness of that thing is dy. Okay. Now the distance here, okay, is not, so unfortunately that's not x, which is what we'd like it to be, because x is from here to here. So it actually turns out that it's 1 meter, that's this distance, minus x. So this is 1 meter minus x. Okay, just from the geometry. Okay, so now we need the x bar. So that's this little spot right here. Okay, so that's going to be, let's see, how do we do that? Well, I'm going to need a little bit of space here. The x bar equals, well, that's going to be x. So right there, x plus, okay, half of this distance, which I decided was 1 meter minus x divided by 2. Okay, so I think if we do some math on that, let's see, that's x minus x over 2. So that's x over 2, I think. Yes, plus a half. Is that right? Did I do my math right there? X plus a half minus x over 2. Yeah, that's right. So maybe I can make that x plus 1 over 2. Probably the easiest way to do this. Let's make it x plus 1 over 2. Or actually, let's make it 1/2 x plus 1 meter. Okay. And then y tilde equals, let's see. So y tilde, well, that's just y. Okay. Before I go on, any questions? Okay, I totally expect that this is confusing the first time you see it, or it's a mind twister. And what I'm going to do here is next class, unless somebody wants me, I might do like one composite, and I'll do like as many of these as we can fit in, because I do think that these are confusing. But let's go ahead and then let's just start plugging and chugging. Okay, and basically we only need to solve this one way with either horizontal or vertical boxes, and you're just basically going to look for the easiest one. Okay, so here's my x bar. Okay, so it's x tilde, so it's x over dA, which is going to be, I'm going to change the order here, y dA, like y dx, sorry, excuse me, dx, and here's the integral. Okay, and underneath it, I'm going to do the integral of the dA. Okay, come on, give me my integral. Integral of dA, which is going to be y dx. Okay, that looks pretty nice. I'm not going to lie, it looks nice. Now, the way we solve this, though, is we have to look at this dx. So this is an x. So we want to do, first we need to get our limits of integration. So we're going in x. So we're going from x equals 0 to x equals 1. So this becomes 1 meter and this becomes 0, 0 and 1 meter. Okay. And then those y's, so we want everything to be in terms of x. So everywhere we see a y, we're going to plug in kx to the fourth. Okay, so this looks like x bar equals integral of x times kx to the fourth dx over the integral of kx to the fourth dx. Okay, to me, that looks solvable and not too terribly difficult. Okay, let's go ahead and do x bar with the horizontal boxes. Okay, and so we're going to do the same thing. I'm going to integrate from, well, let's see, we're not going to do that yet. So y tilde is y. Okay, dA is 1 minus x. Okay, times dy. Okay, divided by that dA on the bottom. So we're going to integrate from, let's see, so it's going to be 1 minus x dy. Okay, now I need the limits of integration. So those y boxes go from 0 down here, okay, all the way up to k. So 0 to k, 0 to k. Okay, again, I'm going to note that I've got a y here. So I want everything to be in terms of y, so I'm not going to have this x. Unfortunately, I don't have it in terms like that, so I need to solve this. So y equals kx to the fourth. So x to the fourth equals y divided by k. So x equals the fourth root of y over k. So now I'm going to say, well, x bar equals the fourth root. Well, let's see. So we're going to just integrate y times 1 minus the fourth root of y over k dy over the integral of 1 minus the fourth root of y over k dy. All right. Now, I think if you guys are looking at this, these should equal each other. Okay. Unless I've made a mistake, they will equal each other. So if I ask you on a homework assignment, as I have this week, I said, set up the integrals in the x and the y. Okay. Set the integral up. So this is what I'm looking for. Set this up. But then what I want you to do is I want you to choose the one that you want to solve. Okay. Now, hopefully most of you guys, I mean, if you want to solve this one, go right ahead. I don't particularly want to solve that one. I did on my key, actually, just in case somebody did it that way, but it's totally annoying. If anybody wants, I should actually post that test to Moodle for you guys. But I mean, I don't know why anybody would do this if they had an option. So what I'm going to do is I'm going to erase this. Okay. And if you want, I can come back and I can solve that for you. But the idea here is let's find the path of least resistance. Okay. And for some of you are now like, some of you, because calculus is, like we ask you to do a bunch of calculus, and then we never ask you to use it. So this is going to be a little bit, this might be a little bit rusty, and that's okay. So this is going to be the integral of kx to the fifth dx over the integral of kx to the fourth dx. Okay, so we're going to use whatever they call it, the exponent rule. So this becomes kx to the sixth divided by 1/6. Over, this becomes k. Remember, k is a constant, so k doesn't matter. X to the fifth divided by 1/5. Okay, and both of those go from 1 meter to 0, 1 meter to 0. Okay, and so, oh, sorry, we need my x bar. These need to be equations. So if we plug that 1 meter to 0 in, I get what, 1/6 over 1/5, which becomes 5/6. Okay, so it's not even a function of k. K doesn't even matter in the x direction. Okay, so if we look at that before I move on, so x bar equals 5/6. Okay, note that this is 1 meter from here to here. and X bar is 5/6 of the way over here. Okay, it's somewhere along like a line like this. It's way far over to the right. And the reason for that is because there's so much more area to the right over here than there is over here. Okay, so we always want to be thinking about along those lines if we can. Okay. Any questions about that? Okay, just pick the direction that makes it easiest. Okay. So so let's go ahead and do the direction of the Y. It might be good in some ways if you wanted to. You could even like remember that the area on the bottom, which I didn't actually solve for. So the area is 1/5 K times 1. So it's 1/5 of K. That's the area on the bottom. So we could reuse that without even doing any work. You know, so I could just, you know, plug that in right here and do 1/5 of K because we've already solved that if you wanted to. Okay, but let's go ahead and we're going to pretend we didn't do that. Okay, because maybe I give you a problem where I only ask for Y bar, you know, which certainly is completely reasonable. And the only reason I would do that, because you usually want Y bar and X bar, but the only reason I would do that on a test is because I just want to test your ability to know this, but I don't necessarily want you to spend the next like 30 minutes of the test working this one problem so you can prove to me twice that you know how to do it. Okay, so so we'll just go ahead and assume that you haven't done that yet. Okay, let's come on, erase you punk. All right, so here we go. So all right, so same procedure. Y equals the integral of Y tilde dA over integral dA. Okay, Y bar equals integral of Y tilde dA. By the way, it seems pretty likely in this case that the horizontal box, that the vertical boxes are going to be the easiest either way. But let's just go ahead and set it up and see what happens. Okay, so Y bar equals, well, Y tilde is right here, Y over 2. Oh, that 2 is annoying, but not too hard. dA, well, the dA is right here. So it'll be Y times dx. Okay, and what's on the bottom is the integral of the dA. So it'll be Y dx. Okay, so again, I note that we've got these dx's, so everything needs to be in terms of x's. So Y bar becomes, I'm actually going to take this 1/2 out because I don't really want to deal with it. So it's going to go 1/2 integral of Y squared. Y squared. Okay, so that means we've got this thing squared. So it's going to be K squared x to the 8th dx. Okay, over. Now on the bottom, I've just got a Y. So it's going to be K x to the 4th dx. Okay, hopefully you're looking at this and you're thinking, okay, I could probably do that. I don't know, you know, but that is solvable. Okay. Yeah, so let's go ahead and do this side. So Y bar equals the Y tilde, which is Y, that's easier. Okay, and then the dA is going to be 1 minus x dy. Okay, it doesn't look too bad. And on the bottom, the dA is 1 minus x dy. Okay, so, all right. So again, the problem here is we need to, you know, everything needs to be in terms of y's. So I've got this, wait, oh yeah, so I need to turn these x's into y's using this relation over here. So I get the Y bar equals, let's see here, integral of Y times 1 minus the 4th root of Y over K dy over the integral of, what I mean, I guess the 1 minus the 4th root of Y over K dy. Okay, so let's do it like that. Okay, so my guess again, you know, if I ask you to set it up, which I guess I could do that on a test too, that would actually be a nice way to save time. Just say set it up. Okay, between the left and the right, hopefully most of you guys I think would choose the one on the left. The one on the right can be done. It's not like impossible, but you're going to end up keeping track of a whole bunch of like fractional exponents. It's not fun. So we're not going to do that one if we can avoid it. So let's not do that one. Okay. And so we're going to erase all that junk, and we'll solve the one on the left. Come on, erase. Okay, you can do it. You can, come on, you can. It's really annoying. All right, so we'll go ahead and solve this one. Okay. Oh, we need limits of integration. This is dx. So it's going to go from 0 to 1. Okay, so 1/2 integral from 1 to 0. Actually, we're just going to go ahead and do the integration step. Okay, so the k squared is a constant, so it gets pulled out. And I'm left with 1/9 x to the 9th. Okay, and that's going to go from 1 to 0, 1 meter to 0. And then on the bottom, we've got the k gets pulled out. It's a constant, so we're not worried about that. X to the 5th, 1/5 of that. And then we're going to go from 1 meter to 0. Okay, this is a parenthesis. I know it doesn't look like one. All right, so nice thing here, the limits are 1, so this becomes like a lot easier to solve. So the top becomes, what, that becomes 1/18, k squared over 18 on top, I think. K squared over 18, yeah. And on the bottom, we end up with k over 5. Okay, so again, this is all y bar. So we can say y bar equals 5k over 18. Okay, so depending on what k is, this is what's roughly a third. I mean, it's between a third and a fourth. So it's going to be, I don't know, maybe like right in here. So if I were to go over, maybe like right here. And again, we would expect this thing to be closer to the bottom because there's more area down here than there is up here. Okay, so we would expect it to be closer to the bottom. Okay, so I know there's no time for me to start another one, but any questions on this? Okay, I'm imagining for some of you this is like a little bit mind-blowing. I tried to go as slow as possible. We'll work a few more of these on, I guess on Monday. No, I guess we won't do it on Monday because we have a test on Monday. We won't do it on Monday, on next Wednesday. But any questions on this procedure? Okay, I'm getting radio silence. So hopefully that was helpful. I know when I did this, I would have actually really could have used some extra time just watching somebody work it. So I hope it was at least a little bit, you know, sometimes when y'all are quiet, I'm like, I'm either doing great or I'm really bombing. So I can't tell which one it is. So anyway, that's all I got. So if you have no questions, I guess we'll call it a day.
Just to clarify, centroids aren't on the exam, right?
Right, they're not on the exam.
Yeah, it looks familiar to stuff we've done in calculus, so just listening.
Okay, yeah. I mean, it's straight up a calculus problem, you know. But depending on how long it's been since you've had calculus, I'm always critical of the fact that engineering schools, UNO is no different, spend a lot of time teaching you calculus, and then we just kind of like, it just kind of shows up in your engineering classes like once a semester, and it's like, surprise, you're supposed to remember all that stuff. And you know, I think we should teach way more of it with calculus, and by the time you got out, calculus would be second nature. But you know, I'm in the minority on that. So anyway.
It's a good refresher.
Yeah. So all right, well, that's all I got then, guys. Guys and gals. Is guys gender neutral? I don't even know.
I mean, it's not, but it's fine.
Yeah. Well, folks, you know, peeps.
Anyway,
Anyway,
let's just stick with y'all.
Y'all, I like y'all. Y'all is a wonderful, wonderful word. Anyway, so I hope y'all have a good day. And I guess really for us, I won't see y'all this weekend. Since the test is on Monday, I'll probably have a a review session, or maybe not review session, I'll create an office hour on probably Sunday night if you guys need it. If you have like any specific concerns and you're like, I can't make that time that I set up, just send me a thing. We can meet anytime. Okay.
I have a comment about the homework.
Okay.
So the problem map on the practice assignments, I reached out to them about not being able to skip questions, and they said that's something the instructor sets.
Did they say
Yeah,
what it was?
so I'm sorry.
Did they say what it was?
He just said it's one of your settings. I like to be able to kind of like go through and look at different problems, but it's got it to where if I skip one, it resets the whole assignment.
Oh God. And that's for the practices or for the
Yeah.
homework?
It hasn't been like that until these last couple assignments I was trying to do. So
Oh,
I
so
didn't know if it was intentional.
is it for the practice or for the homework?
I'm not sure. I just tried it on the practice.
Okay, well, can you try it on a homework and let me know if it does it, and then I'll try to figure that out.
Okay, yeah.
Okay, cool. All right. Well, I got to run. It appears my dog has just arrived home. So, so yeah, send me an email and then I'll call McGraw Hill and try to figure that out.
Okay, sure will.
Okay, thanks. All right, see you guys.
Bye.
Thanks.
All right. I'm going to stop recording. Hold on. Stop recording.